Okay, physics. Last video on derivatives for physics E. So, really a couple things I want to do. So, just want to walk you through an example really briefly, and then point you to the formula sheet, and so you know where to look for things. And if you're looking for something, again, this is not a class about math. It's about a class using math. So, if you ever don't know how to do something, you just look it up. So, you're allowed to have a calculator for the test. So if you have a calculator that does integrals and derivatives, right, you don't even have to know it. But if you're, but it would be good to know how to write these things out. So let me talk you through. So brief example. So again, derivatives. So really the most common thing we're going to be doing is using the power rule and separating these things. So if I have a function, if I ever see a function, I want to be thinking, oh, calculus is going to be involved. That's a function for position. So if I wanted to get to velocity, so velocity is the rate of change of position with time. So in calculus, this is going to be how much this changes. So I'm going to take the derivative of this function, right? And when I do this, right, so first I can distribute this. So my velocity function of time is going to be the derivative of this plus the derivative of my second component. And I'm going to take the derivative of this, right? So my 15 is a constant. I'm going to pull that out. So this is going to be 15 times the derivative of x cubed. Remember how I can do this? So this is the power rule. So I'm going to multiply by the original exponent and make a new exponent that is one less. And here I'm going to do the same. I'm going to pull this constant out for t. That's the t. I'm going to multiply by my original and then have a new exponent, which is one less. Right? So I have a new equation for velocity, represents the instantaneous. So at any point in time, I can plug in time and I can find out what the velocity is at that point. So, and I'll simplify this. This is going to be 45 x squared plus 8 t squared plus 8t. So function of time. So notice that the 45 and the 8 are going to have units associated with them, right? So I need this to come out to meters per second. So if I multiply by t squared, right, my 45 is going to have units of meters per second cubed. Whew, good grief. It's ugly. You just got to make it work. 8, I'm going to multiply that by time. Remember, time is always going to be in seconds. So this 8 is going to have a unit of meters per second squared. So I multiply it by like 2 seconds and end up with meters per second. So the units have to work out. Really, we don't worry too much about units, but you should know how to do it. So there are 3 other things that I'm going to ask you to look up, and just so you get a little bit familiar with, because you'll come across them once in a while. So that's the product rule, the quotient rule, and then the general power rule. So general power rule is really handy if you get your head around it, but don't worry, you're going to go into these things much more detail in your calculus class if you haven't already, but you will go into them in more detail before you really need to use them very much. So the more complex calculus really comes into play in second semester. So this is probably as much as you need to know first semester. So take a brief look at the formula. So here's the formula sheet. So the last page of the formula sheet includes a whole bunch of stuff, including like the area of a rectangle, right? Surely you know that, right? But it also has this list of calculus things. So let me walk you through these really briefly. So the first one, I'm looking at the U substitution. So we will use U substitution in some places, and we will get into that, but really that's second semester. So the first one is not so relevant for first semester. The second one is the power rule. So this is what we just did. So it is describing how you take the derivative of something that's raised to an exponent. The third one we'll come across a lot second semester. So when we get into electricity and magnetism, especially, that we end up having we use the exponent e, which turns out to be a really handy constant for things. So we will take the derivative of something that is e raised to the power of something, and that's shown how to do that. Similarly, we'll come across natural logs, primarily second semester. So taking the derivative of a natural log is going to leave you with an inverse. This semester we will get to sine and cosine, so we will use sine and cosine for looking at circular motion and also harmonic motion, and then we'll use it a bunch second semester. We'll get into, turns out it's really handy for electricity and magnetism as well. So the derivative of the sine is a cosine. Be careful about how you do that. We'll get into those examples later. And derivative of a cosine is negative sine. So and those two will show up a bunch. So really, primary thing, though you want to get comfortable with this, is just this example that I went through for first semester. That's going to be most of what you need to know. A little bit of sine and cosine. Anyway, I hope that's helpful, and talk to you soon. Bye.